Carboxylic acids are the highest priority functional groups. They are represented in three different ways. A carboxylic acid is made up of a carbonyl that is connected to the OH. Let's say, for example, if you have a molecule that has multiple functional groups, one of them is the carboxylic acid, then in this case, your acid will be the highest priority. This is the priority order of different functional groups. Carboxylic acid is all the way to the top, meaning that carboxylic acid is favored over any other functional group. The ending is always going to be in carboxylic acid when it is present in there. The rest of these functional groups we're going to cover in the coming chapters. Carboxylic acid are named either by an IUPAC or by a common name. To name carboxylic acid by IUPAC, you're going to drop the E ending in either the alkane or the alkene. So, or the alkene. So you're going to drop the E in the alkene or the E in the alkane, and you're going to replace that by oic acid. Start numbering. Always the carbonyl of the acid needs to take carbon number 1, and then you give your substituents the lowest number possible after you number your carbonyl number 1. Any other functional group in the molecule will be named as a prefix, and these are the names of the functional groups. If you have an OH, you're going to name it as a hydroxy. NH2, you're going to name it as an amino. A carbonyl, you're going to name it as an oxo, and that carbonyl is going to be general for an aldehyde or a ketone. If you have an aldehyde coming off the chain, then we're going to name this as a form or formal. Let's have an example over here. So choose the longest carbon chain that includes the carbonyl of the carboxylic acid. Give the carbonyl of the acid carbon number 1, and then number your substituents in there. So this is 4, this is 5, this is 6, and this is 7. 7 means that this is a heptane. So all what you need to do is simply take the E in the alkane and replace this by oic acid. And then name your substituents and name them according to alphabetical order. So the OH is hydroxy and the NH2 is amino. So amino comes first, so that is going to be 5 amino, 3 hydroxy, heptanoic acid. For this example, we're going to start from the carboxylic acid, and we're going to try to include all the functional groups, or as much functional groups as we can. Even though if the chain that we choose is not going to be the longer carbonate chain, it's fine as long as it includes most of the functional groups in there. So over here, I've included the aldehyde as well. Even though including the aldehyde will result in a shorter chain, because if I went all the way like this and I included the ethyl, I'm going to end up having a longer carbonate chain, but now the aldehyde will be left out. So this is why you include all your functional groups in there. The alkane is not a functional group, so you don't include that. You start numbering always from the acid, so that is going to be 1, 2, 3, 4, 5, 6, and 7. Now, when the carbonyl is included in the chain, we name it as an oxo. It doesn't matter, either an aldehyde or a ketone. If it is included in the long carbonate chain, we name it as an oxo. So the name here, we arrange the substituents in alphabetical order. So here I have a propyl, I have an ethyl, and I have an oxo. So the E is going to come first, and the name is going to be 6-ethyl, 7 oxo, and then 2 propyl, There's no space here. Heptanoic acid. Another example over here. Now see, I have three functional groups, but I cannot include them all. So now I'm going to go with the route that goes with the longer carbon chain and includes at least one substituent in there. So here you go. I included one aldehyde, but I have another aldehyde that is a substituent, and I want to differentiate between them when I want to name them. This is when I use form in there. So form, I use it whenever the aldehyde is a substituent of the long chain. So now I'm going to start numbering from the carboxylic acid. This is going to be 1, 2, 3, 4, and 5. 5 oxo. Now on 3, I do have an aldehyde. And that aldehyde, I cannot name it as an oxo because it is not part of the chain. So this is why I'm going to name it as a formyl in this case. So F comes first in alphabetical order. So it's going to be 3 formyl. Okay, this means that 4 means it's an aldehyde. So this means that it's an aldehyde branching off the longer chain. It is not on the chain. And then on carbon number 5, I have the oxo, means that that carbon belongs to the longer chain in there. And then I'm going to have 5 oxo. And then this is going to be a pentanoic acid. If we have 2 carboxylic acids, then we're going to use the prefix di in front of the carboxylic acid, and our longer chain needs to include both of these carboxylic acids in there, both carbons. We're going to start numbering from the carboxylic acid that is closest to the first substituent. So that is going to be 1, 2, 3, 4, 5, 6, 7, and 8. So that is going to be an octadioic acid. You're still ending the name in the oic acid in there. All what you're going to do is put the prefix di. Okay, don't forget that. And then our substituents in there. So we have 3 hydroxy and 4 methyl. So that is going to be 3 hydroxy, 4 methyl octadioic acid. Now, if we have an alkene in there, we have to choose our longest carbonyl chain, including that carbonyl of the acid and the carbonyl. Our ending in this case needs to be in the carboxylic acid. 1, 2, 3, 4, 5, and 6. This is a chain of hexene. Okay, this is an E. So we said that drop the E of the alkene and add oic acid in there. And you need to specify where your double bond is. So your double bond is going to be on carbon number 5. So that is going to be 5 hexane oic acid. Already we know that the oic acid is on carbon number 1. Then definitely the double bond is going to be on carbon number 5. Same thing over here. Choose your longest carbon chain that includes as much functional groups as you can. So here you go. I have a ketone in this case. So I would need to include all of these carbons in there. Start numbering from the carboxylic acid. Give it the lowest number. This is 4, 5, 6, 7, 8, and 9. This is nonene. So I'm going to go ahead and drop the E, take it out, and I'm going to replace it with oic acid. Number 3, I do have my double bond. So this is the 3. This is for my double bond in there. And this is why I need to include it before the nonene. And then my substituents. I do have a methyl substituent. And I do have an oxo substituent in there. So arrange it in alphabetical order. The M comes first, so that is going to be 4-methyl, 8-oxo, 3-nonenoic acid. By looking at it, this is a chain of 9 carbons. So if the oxo is on carbon number 8, immediately I know that this is a ketone and not an aldehyde. So this is why I said that the carbonyl, we use an oxo as a prefix, whether it's an aldehyde or a ketone. Unless the aldehyde is coming off the main chain, then we use the prefix form. Now, if we have a carboxylic acid coming off a cycle, in this case, then this carbon over here, we are going to call it carb. And then we look at the functional group. What type of functional group is this? And that would determine what comes after the carb. So this is a carboxylic acid. So this is why I'm going to name it a carboxylic acid. If it's an aldehyde, then we're going to name it as a carb aldehyde in there. So the carbon that is coming off the cyclohexane, we call it a carb carbon. Okay, so that is a carb, the bromine. My ending is going to be in carboxylic acid because the carboxylic acid has the highest priority. That carboxylic acid is on a cyclohexane. So the ending is going to be a cyclohexane carboxylic acid. So the ending is going to be a cyclohexane carboxylic acid. And then I'm going to give my carboxylic acid carbon number 1 because it is the highest priority in there. And I'm going to name the substituents on the cycle. The carboxylic acid is one of them. So that is going to be priority number 1. Between the methyl and the ethyl, if I go this way or I go this way, both are going to get the same number. So I go with the priority in alphabetical order. So the E comes first, so I need to go this way. It's going to be 2. That is going to be 4. And that is going on 2, 3, 4, 5, and 6. And that is going to be 6. So I'm going to end up having 4 bromo, 2 ethyl, 6 methyl, cyclohexane carboxylic acid. I want you to differentiate between a carboxylic acid coming out of a cyclohexane and a carboxylic acid coming off the benzene. So over here, if I have a benzene, there's a big difference between a benzene and a cyclohexane in there. The difference is this carbon over here, because this carbon, we called it carb because it is connected to a cyclohexane. This carbon over here, we all know that this is the benzylic carbon. There's a difference between a carb and a benz. So this is a benzylic carbon. This means that it's connected to a benzene. So when I want to name this acid over here, it's going to be a benz. And then whatever comes after the benz will depend on what type of functional group I have. If it's an acid, then it's going to be benzoic acid. If it's an aldehyde, it's going to be benzaldehyde. So that is going to be benzoic acid. Let's say, for example, if I want to name this structure over here, the carboxylic acid is going to be on carbon number 1. The ethyl is going to be on carbon number 4. This is a para-substituted, di-substituted benzene. So please use para, orthometa, or para whenever you have a di-substituted benzene. Instead of using 4, don't use 4. Use para in this case. So the name is going to be para, ethyl benzoic acid, So in this case, the benzoic acid is going to be the common root for the name in this case. This is why I'm starting with 1 in the benzoic acid and ending up with 4 in the ethyl. Common name is used to name short carboxylic acid chains. And to name carboxylic acids in common, you are going to drop the E in the alkane and you're going to replace it by an ic acid. You are responsible to name up to 6 carbons in common name. So 1 carbon is formic, 2 carbons is acidic, 3 carbon is propionic. Notice that all of these common names, I am ending them in ic acid, not in oic acid, in ic acid in there. So this means that this is a common name. Up to 6 carbons. So 5 carbons is valeric acid and 6 carbons is a caproic acid. Now, if you have any substituents, we don't use the numbers 1, 2, 3 with common. We use the Greek letters. And the Greek letters are alpha, beta, gamma, delta. I'm going to add one more, which is omega. W is omega in there. And this is on carbon number 6. So if you have carbon number 6 in there, that is going to be an omega carbon. So if your substituent is on the alpha carbon, you are going to name it as an alpha methyl. And then do exactly the same. You're going to choose your longest carbon chain that includes the carbonyl of the acid. Here, this is 4 carbons, and I know that 4 carbons is a butyric acid. On the alpha carbon, I have a methyl, so it's going to be alpha methyl butyric acid. The amino is on the gamma, so that is going to be a gamma amino butyric acid. If you want to name this structure as a common name now, give the Greek letters to the substituent. So you have an alpha over here, beta, gamma, delta. So your oxo is on the delta. So the common name is going to be delta oxo. Okay, don't use numbers in there. And then I know that 6 carbons is a caproic acid, so that is going to be a caproic acid for those. Now for the diacids, there are 2 diacids that we will be working with their reactions. The propane dioic acid and the ethane dioic acid. Those have common names as malonic acid and oxalic acid. You don't have to know their common names in there, but just be familiar with these names because you are going to see those names in the coming chapters. OH is always named as a hydroxy in presence of the carboxylic acid. So for this one, you're going to have an ortho-hydroxy benzoic acid. If you have 2 carboxylic acid coming off the benzene, then this is going to be benzene. It's going to be di. Both of these carbons, in this case, you cannot use benz anymore. Pay attention because you do have more than 1 carboxylic acid. So you have to use a carboxylic acid in this case. And this is the only exception. So benz, you use it whenever you have 1 carboxylic acid coming off the benzene. But if you have more than 1 carboxylic acid coming off the benzene, then you have to name it as a carboxylic acid and use the prefix, whatever prefix, depending on the number of the carboxylic acids that you have coming off the benzene in this case. Here I have 2 of them, and they are ortho with respect to each other on the benzene, so put an ortho in there. We know that carboxylic acids have an acidic hydrogen. So when carboxylic acid reacts with a base, the base comes and takes that hydrogen over here and form a negative charge on the oxygen. So now what you created is a conjugate base. That conjugate base is the salt of the carboxylic acid. Salt of the carboxylic acid. Now, in order to name the salt of the carboxylic acid, you start by naming the metal cation first. This is going to be sodium, so you name it first. And then you name the parent name, either common or IUPAC, it really doesn't matter. You drop the ic acid in both the common and the IUPAC name, and then you replace that by ATE. So your ending is going to be ATE. So the name of this one is going to be sodium. This is 2 carbons. So instead of being acetic acid, you drop the ic acid, it's going to be acetate. And instead of being ethanoic acid, you drop the ic acid, it's going to be ethanoate. This is another example in here. Start with the metal first. So that is going to be potassium. And then number from the carbonyl. So this is carbon number 1, this is carbon number 2, this is carbon number 3. In case you have any substituents here, I have a methyl substituent. So that is going to be a 2-methyl. Your longest carbon chain in this case is going to be the propanoic acid. You drop the ic acid and it's going to be propanoate. If you are naming this as a common name, this is an isogroup. And it is a butyl group, including that carbonyl of the salt, of the acid. So this is why you're going to name it as an isobutanoate.